In this video, we present Gallery Filter Network for Person Search, a novel model which uses global scene features to improve person search efficiency and accuracy. I'm Luke Jaffe, and this work is conducted jointly with Professor Avideh Zakhor at UC Berkeley. In Person Search, the goal is to localize a query person in a set of scene images called a gallery. Person Search can be divided into two steps. First, person detection, in which we localize each person in every gallery scene, and second, person retrieval, in which we compare a query person to each detected person and sort them by similarity. If we want to do person search efficiently, then we need to address a problem. Object detection is expensive. In practice, for person search, about 1/3 of the time is spent on computing backbone features, and 2/3 of the time on detection and embedding. To address this high cost, we considered two potential solutions. One, we could reduce the cost of detection by using a cheaper detector model, or two, we could short-circuit the person search process for unlikely scenes before detection, avoiding the expensive cost altogether. This is the approach we consider. Our model is called the Gallery Filter Network, or GFN, which avoids object detection by splitting person search into two phases. First, scene retrieval, in which we rank scenes by likelihood they contain the query person, and second, person retrieval, in which we detect and then rank persons by similarity to the query person. If a given gallery scene scores lowly in the first phase, we can avoid the second phase and save significant computation. To implement this two-phase process, we need a person search model in addition to the Gallery Filter Network. Our person search model is called SeqNeXt, which improves upon the previous SeqNet model with an upgraded backbone and more aggressive augmentation. The person search model takes query and gallery scenes as input, detects and extracts embeddings, and compares query and gallery embeddings to produce a re-ID score. In addition, the person search model produces scene embeddings from the same set of backbone scene features. Person and scene embeddings are fed to the GFN, which produces the person scene probability used to threshold out unlikely scenes. Lastly, these GFN scores are combined with the person re-ID scores and detected box scores to give the final scores used to rank detected boxes. To review, the goal of the GFN is to output a high score when a person is in a scene and a low score when they are not. To implement this, we use a standard contrastive learning objective, which maximizes cosine similarity between person embeddings and scene embeddings when a person is in a scene, and minimizes this similarity when they are not. Although this objective is functional, we improve on it considerably with our final objective by combining person and scene embeddings. This deconflicts the optimization, yielding much better results. We evaluate our model on the two standard person search benchmark datasets, CUHK-SYSU and PRW. For person re-identification performance, the SeqNeXt model combined with GFN score weighting achieves state-of-the-art results on both datasets using the two standard retrieval metrics of mean average precision and top one accuracy. For filtering gallery scenes, we showed that the GFN is effective, but that its performance depends on the visual diversity of the dataset. For the visually diverse CUHK dataset, the GFN more easily thresholds scenes than for the more homogeneous PRW dataset. Since 60% of model computation time is spent on detection, we can improve time savings depending on how much we are willing to reduce scene recall. On the CUHK dataset, for a 95% scene recall requirement, MAP is reduced by 5%, but we achieve more than 50% time saved. On the PRW dataset, for the same requirement, MAP is reduced by 3%, but we achieve only around 10% time saved. Therefore, it is important to consider visual diversity of the dataset when using the GFN for scene filtering. To conclude, the GFN improves person search efficiency by filtering gallery scenes, accuracy by weighting re-identification scores, and modularity in that it can be combined with any person search model. That concludes our presentation. Thank you for viewing.